Hi everyone, my name is Haley and my dad's going to teach you earth science. Hope you have fun. Stay safe. Bye.
All right, guys, welcome to Coronavirus Earth Science. We are starting the next unit, which is Unit 9, Weather. This is a massive unit, so we're going to take our sweet time with it. All right, one thing that you should notice if you go into your OneNote, this way no one's confused, because we definitely had some confusion out there. I pushed out a section to you guys. So you'll see everyone now has a Unit 9 weather folder, okay? Every single person has it, okay? There's nothing in it because you're going to go copying stuff in one by one, but I just wanted to let you know everyone has a folder now that says Unit 9 weather, and that's going to be where you copy all of your pages for each day. All right, and remember, you could do that one of two ways. You could just copy it straight from the content library, like we have been all year, or you can do what I showed you in my first video, which is when you take it from Schoology. All right, so right now, today is day one. Really, it's just a note sheet and some summary questions. I'm going to take you through the PowerPoint. We'll be done in 2 shakes, and you'll be good to go for today. Okay, so day one, heat versus temperature. So in your reference tables, there is a page or two that we are gonna be using for within the next 2 days. So I'll let you know where we're going. So just make sure you have it out. Homework this week, you got Geologic History Castle Learning. It's kind of like a wrap up of the entire unit. It says post-test, but it's not counting as a test, but it will count as a grade, all right? You are getting a grade for it. And then I put up a Google form that I want you guys to also have done by Friday. Everything get done by Friday so that I can check on Saturday. All right, here we go. So here, we're converting between Fahrenheit, Celsius, and Kelvin. Now, in order to answer these questions, you have this chart, this diagram on the right, which also just so happens to be in your Earth Science reference tables, page 13. Okay? And one important thing before we move on is to know what each scale is going up by. So in Fahrenheit, they're going up by 2s. In Celsius, they're going up by 1s. And in Kelvin, they're going up by 1s. All right, and it's really simple on how to use it. The first question says a temperature of 80 degrees Fahrenheit, so that's right here. What would that be in Celsius? So you're just going to come and read straight across. And so this is, 20, 21, 22, 23, 24, 25, 26, 27. There you go. So 27 should be your answer in Celsius because these are going up by 1s, right? A temperature of 104 Fahrenheit, 104, remember these are going up by 2, so you're right here, would be equal to what in Celsius and what in Kelvin. So in Celsius, it's going to be 40, and in Kelvin, it's going to be about 313. So in this one, your answer is D again. Really simple. You find the number and then just read across. But what I said, make sure that you pay attention to the scales, okay? Make sure you know what they're going up by. All right, so heat versus temperature. Heat is a type of energy, and it can be transferred from one object to another. The unit is joules, okay? Whereas in temperature, all right, this is a word that you guys have already learned, is a measure of kinetic energy, and kinetic energy is the energy of motion. All right, so just remember, heat is energy, all right? And the more energy you have, the more motion there will be, right? The more heat those molecules get, they're going to have more energy, they're going to move faster, and that's why their temperature goes up. The opposite of kinetic is potential, which is stored energy. All right? So how do we measure our temperature? Again, this is that little scale that I was talking about before. So we're just going to go through this chart and get our numbers. So if you have, again, twos, ones, right? So that we remember what they're going up by. If you have 0 degrees Celsius, which is right here, what is that going to be in Fahrenheit? You would end up right there, right? And these are going up by twos. So that is 32 degrees, right? So this is 22, 24, 26, 28, 30, 32. Okay? Next one, 100 degrees Fahrenheit, which is right here. 100 degrees Fahrenheit, what's that going to be in Celsius? You're just going to come right across. You should have around 38, right? Because these are going up by 1. So if this is 30, this is 35, 36, 37, 38, okay? And again, usually they'll give you that little bit of cushion. Lastly, you have Kelvin, which is a totally different scale of temperature that is used, and I'll explain to you why in a second. But if you have 20 degrees Celsius, which is right here, that's going to be approximately 293 Kelvin. All right, and the reason why we have Kelvin is that the numbers are very different and drastic. Look, 0 degrees Celsius, which is freezing, right? It says it right here. Just so happens to only be about 273 degrees. So there's a lot of cushion in terms of how cold it can get. So that's why we have Kelvin. Absolute 0. This is going to be on your quiz on Friday. The lowest possible temperature. This is when it gets so cold that there's no energy and the molecules totally stop moving. All right, and here you have all three temperatures, right? 0 Kelvin, which is negative 273 Celsius, which is negative 459 degrees Fahrenheit. Think about that. That's what we really know. That is super, super cold. All right, so at that temperature, at absolute 0, that's so cold that the molecules have 0 energy and they don't move at all. Okay, so how does heat energy flow? Heat always goes from hot to cold. The hot part is called the source, and the cold part is the sink. All right, so when you put ice in your water, the heat is going from the water to the ice. And since the water is losing heat, that's what makes your drink colder. Okay, here the heat is going from the soup out into the air. Have you ever been yelled at for keeping the air conditioner on and your windows open? Right? Your parents or whoever's in charge of you will be like, hey, close that window, you're letting out the cold air. Well, if you want to be a pain in the butt, you can correct them and say you're not letting out the cold air, you're actually letting in the hot air. All right? Because when you are cold, you're not getting colder, right? Cold isn't something that you get. Cold is just the absence of heat. Heat energy is what you keep track of, not cold. Okay, so now we're going to talk about something called specific heat. So if we were heating up a kilogram of copper versus a kilogram of water, one is going to heat up a whole lot faster than the other. And I think you guys should know this. That is going to be the copper, right? Metals heat up really, really fast as opposed to water. And this is because of something called specific heat, all right? And this is actually the page 1 of your reference tables, all right? It's basically the amount of heat energy that you need in order to change temperatures, all right? So if you have a low specific heat, which is water, it takes a high specific heat, sorry. If you have a high specific heat, it requires a whole lot of energy to change temperature. That's why it happens very slowly. It's going to take a long time to change temperatures, okay? versus something that is metal, which has a low specific heat. Things that have a low specific heat happen very quick. They change their temperatures very quick, so that means it's a short amount of time. If you put a pan on your stove, the pan heats up very, very fast, and it cools down very fast because it's a metal. Metals are good conductors. Heat travels through them very well. If you're boiling water, it takes a while for that water to boil. All right, so make sure you know the difference between high and low. All right, so right here, this is that page 1 of your reference tables. Okay, water has a high specific heat. That means it's very slow versus, look, metals are very fast. Okay, so 2 different types of metals. Iron had a lower specific heat, so it changed faster. All right, so here's your summary questions. I want you to go through them. You can do these on your own. They're pretty simple, and I'll post the answer keys in the answer key folder. All right, have a good one, guys. Stay safe, and talk to you tomorrow. Bye.